Assalamualaikum and sejahtera class. Okay, today we will learn on chapter 5. Okay, so on our final chapter, which is also our final chapter, about two-point networks. So we have three parameters in two-point networks that we need to cover. Okay, the first one is the impedance parameter. Okay, so first of all, so we have to go for the definition of two-port network. Or of the port, which means of port network. Okay, so a port network, is a pair of terminals. Okay, it's a pair of terminals. We have two terminals, means we have two terminals. Okay, which a current, may enter, may enter or leave a network. Okay, so for two-port network, is an electrical network, with two separate ports, for input and output port. Okay, so we have four terminals, which means we have four terminals, which a pair of terminal we consider as a port, one port. Okay, so the other terminals we have considered as another port. Okay, so this port, the first port, is the input port. Okay, the next port or the second port here is the output port. Okay, so these two ports we call as a two-port network. Okay, so which also mean here, one port, which has a two-port terminal circuits. Okay, so one port have two terminals. Okay, the first terminal is where your currents will enter the network. Okay, and then the second terminal. Okay, in this port, which is your current may leave the network. Okay, so for two-port network, we have two separate port. Okay, the first is the input and the second is the output port. Okay, so we have four terminals since for one port, we have two terminals. Okay, so for two-port network, so we have four terminals at all. Okay, so here we are not consider there any independent source in the network. Okay, so for two-port network, we can also be it can also be categorized into two types. Okay, the first one is where your network is driven by voltage source. So we have a voltage as your driver, driver source. Okay, and then the second one, where your network is driven by current source. Okay, so you have your current source as your main source. Okay, so for impedance parameters, so here, we are using, we have two category, for the impedance parameter. The first one is driven by voltage, and the second is driven by currents. Okay, so for the V1, for the impedance parameter, so this is a general formula for the impedance parameter. Okay, so which is V1 is equivalent to Z11I1 plus Z12I2. Okay, and V2 is equivalent to Z21I1 plus with Z22I2. Okay, if you put in matrix form, so we have the first matrix here is the matrix for V1 and V2, which equivalent to the matrix of Z, Z11, Z12, Z21, and Z22 times with your matrix of I, I1 and I2, which also equivalent to the matrix of Z times with your matrix of I. Okay, so where your Z terms are called the impedance parameter, or simply Z parameters, and all the units for the Z parameter are in ohms unit. Okay, so from this general formula, the V1 is equal to Z11I1 plus Z12I2, and V2 is equivalent to Z21I1 plus Z22I2. So we can obtain, okay, your Z11 and Z12 by connect, okay, a voltage V1 or the current source I1 to your port 1, and you open circuit your port 2. So or if you want to open circuit your port 2, means you zero your I2 here. Okay, you open this output terminal, so means your I2 will become 0. Okay, so when this condition happen, okay, means your I2 is equal to 0. So the impedance, okay, the impedance parameter that you will obtain is Z11, okay, which equivalent to V1 divided by I1, okay, when we consider I2 is equal to 0, and another one is Z21, okay, is equivalent to V2 divided by I2, okay, when your I2 is equivalent to 0. Okay, so here your Z11, okay, is your open circuit input impedance, while Z21 is your open circuit transfer impedance from port 2 to port 1. Okay, so from this general formula also, okay, so the next, okay, impedance parameter that we can obtain, okay, is Z12 and Z22, okay, by, okay, connect your V2 or your current source I2 to port 2, okay. At the same time, your port 1 will open, okay, or your port 1 will be open circuited by, okay, by getting your I1 is equal to 0. So when we open your input, okay, terminal, so means your I1 will become 0. So from here, okay, so you will get Z11 is equivalent to V1 divided by I1, okay, when your I1 is equal to 0 from here, okay, from your general formula here, okay. And another Z impedance, okay, is Z22, okay, when we zero your I1, so you will get your Z22 is equal to V2 divided by I2, okay. And then here your Z12, okay, is your open circuit transfer impedance from port 1 to port 2, and your Z22 is your open circuit output impedance. Okay, so we go to example 1. Okay, so here, okay, you have to determine the Z parameter of the following circuits. So for this given circuit, so you have to determine, okay, the Z parameters. Okay, so the answer given is your Z11 is 60 ohms. Okay, so your Z12 is 40 ohm, Z21 is 40 ohm, and Z22 is 70 ohms. Okay, so we go for the solution. Okay, your first step, okay, so you have to obtain, okay, your Z11 and Z21, okay, by open circuit your port 2, okay, your output port. Okay, so now, okay, from here, okay, when you open circuit your, okay, your port 2, okay, which your I2 is equal to 0. So this is the equivalent circuit that you will obtain or you will have. Okay, so you put, okay, you give your voltage V1 into your source, okay, as your source for your I1 or your input port, okay, and then, okay, this, okay, if you look back, sorry, go to the previous, okay, so here when you open circuit, okay, your I2 here, okay, so this 30 ohm resistor are not longer exist, okay, so your circuit become like this, okay, so you have 20 ohms, okay, and your 40 ohms resistor, okay, so in series with your V1, okay, so I2, remember that your I2 is equal to 0, so only I1 will exist, okay, during this condition when you open circuit your I2, okay, so your V2 here, okay, V2 Okay, you're just using any circuit analysis theorem. Okay, so from here you can see your V2 is equal to 40 I1. Okay, and your V1 V1 here is equivalent to 20 I1 plus with 40 I1. Okay, so directly you can have your since we know that your Z11 is equal to V1 divided by I1. Okay, so Z11 is equal to V1 divided by I1. Okay, so which is equivalent to 80 ohms, right? So from this voltage here, right? Okay, so whereas for your Z21 is V2 divided by I1. Okay, so we can have here directly your V2 divided by I1 is equivalent to 40 ohm. So now your Z11 is 80 ohms and for your Z21 is equivalent to 40 ohms. Okay, so now the second step is obtain your Z12 and Z22 by open circuit your I1, your input terminal. So which means your I1 will become 0. So here when your I1 is become 0, so means if you refer back to your first or your questions, so what you have is only 40 and 30 ohms. So because your 20 ohms 30 ohm resistor is neglected since your I1 equal to 0. So your V1 from this circuit that you have for the condition when your I1 equal to 0, so your V1 is equal to 40 I1 40 I2. And then your V2 is equivalent to 40 plus 30 I2. And then when your I1 is equal to 0, so what you have is V1 divided by I2. So V1 divided by I2. From here we can get V1 divided by I2 is equivalent to 40 ohms. While for your V2 is equivalent to 40 plus 30 I2, which give you your Z22, which equivalent to your V2 divided by I2. That's give you 70 ohms for your Z22. Okay, so now we put your Z in a matrix forms, in a appropriate matrix form. So your Z now is Z11 is 60 ohm, Z12 is 40 ohm, Z21 is 40 ohms, and Z22 is 70 ohms. Okay, class, we will proceed for part A2 later. Thank you.